pi r squared can be used instead, since we know that that base is always a circle. So we've got a cone here. As you can see, they've given us the radius halfway across the base, marked at 5, and the height, which is marked at 6. So we're going to go ahead and dump those numbers into the formula and solve. So it says 1/3 times pi, which we already know is going to be 3.14, times the radius squared, 5 squared, times the height. Well, that's, again, just like in the pyramid, from the circular base all the way up to the tippy top, that's 6. So I'm doing 1/3 times 3.14 times 5 squared times 6. Well, when I do 1/3 times 3.14 times what works out to be 25, 5 squared, order of operations, times the 6. 6 times 1/3 is going to give me 2, times 25 is going to give me 50, and 50 times 3.14 is going to change into 157. So the volume is about 157 cubic yards. Now what they're doing here is, to show the estimation, to show that our answer works, is they decided instead here to let pi roughly equal 3, which is bad math, but the reason they did that here is because then when you're multiplying it by 1/3, 1/3 and the 3 go together to make 1. So we've got 1 times 5 squared, 25 times 6. So we've got 1 times 25 times 6. 25 times 6 is, of course, 150. When we let pi be equal 3, 1/3 times 3 gave me 1. Since that's pretty close to my answer here is reasonable, and this all jives. All right, so let's go ahead and take a look at, check it out examples here. Finding the volume of the pyramid to the nearest tenth, estimating to check whether our answer is reasonable. So again, the formula you got here for the pyramid that we saw in the intro, 1/3 times the area of the base times the height. So it would probably be most helpful if we found the area of the base here. So let's go ahead and find the area of the base. Well, the base, kind of square looking again, but we can see it's not because it's 8 and 7. That means it can't be a square, it's rectangular. 8 times 7, that's going to change into 56. So the formula says take 1/3, multiply it by the area of the base, 56, times the height, how tall this whole guy is here, which happens to be marked at 4. So I've got 1/3 of 56 times 4. So 56 times 1/3, that's going to give me 18.6 with 6 repeating. And then I'm going to multiply that by 4, and that's going to change it to 74 2/3, or 74.6 repeating if you want to write it that way. And that's going to be, in either case, cubic feet, or feet cubed. Finding the volume of the cone to the nearest tenth. Now again, remember, this is the same formula, 1/3 times b times h, but they write the formula so it's specific to the circular base. So instead, they're going to write 1/3 times pi r squared times h. All right, so we've got 1/3, which is just part of the formula, times pi, which is 3.14, times the radius squared. Now, here's one of the ways they're trying to trick you. If we look at what they've given us here, they've gone all the way across the circle, which is, of course, as you know, the diameter. But I don't want the diameter, I want the radius. So if I put 4 in, I'm wrong. I want to make sure I write 2 squared here. And then I'm going to multiply that by the height, which is 7. So 1/3 times 3.14 times 2 squared times 7. I want to make sure I use the order of operations here for that 2 squared, because that's going to have to go first since it has an exponent, 4. 4 times 7 is going to give me 28. Times the 3.14 is going to give me 87.92. And then I'm going to divide that out by 3 for the third, and that's going to give me 29.306 repeating. Kind of an odd answer, but that's what it is, centimeters